In this video, we are going to solve a third rational equation problem. Again, rational equation means our equation we're going to get is going to have a variable in the denominator. We're going to figure out how to solve that. So our third situation is that we have a bus traveling. So it says a local bus travels 7 miles per hour slower than the express. The express travels for 45 minutes. It travels 45 miles in the time that it takes the local bus to travel 38 miles. Find the speed of each bus. All right, so similar to the last problem, I look at this as a rate times time equals distance kind of a problem. So I like to build a box for this just to organize my stuff. So rate times time equals distance. And you have two buses. You have the express and you have the local. And they're traveling at different speeds. So, so it says that the local bus travels 7 miles per hour slower than the express. So we don't know how fast the express travels, so we'll keep it as an R. But the local is whatever the express is, and it's slower, so it's 7 miles per hour slower. It says the same time, so the time is going to be the same on both of these, but the distances are going to be different. So the express travels 45 miles, and the local travels 38 miles. All right, so 45, 38. All right, so it says find the speed of each bus. So let's set up our equations. We have a rate times time equals distance. So rate times time equals distance. Okay, I'm going to leave it a little space because there's going to be a smidge of math I'm going to do here in a second. So then we also have a rate times time equals distance. So if I look at this, they both have R's, they both have T's. I have a system of equations. I can use elimination or substitution. This ends up being a substitution because these T's are very easy to get by themselves because there's really nothing on them. The R is a little bit trickier because of this -7. That R would be easy to get by itself, but I need both of them to be easy to get by itself. So if I go back to this and I say, well, I want to get T by itself, I would divide by R. So then this equation I have T would equal 45 divided by R. So our time is our distance divided by rate. And then over here we would we would take R minus 7, so our T is going to equal 38 divided by R minus 7. So the beauty in that is you have two equations that have T all by itself. So then I can set these two equations equal to each other. Because if this equals T and this one equals T, they have to equal each other as well. So your equation setup is 45 over R equals 38 over R minus 7. So those two fractions equal each other. So it looks bad, however, you just now have a proportion, so you can cross multiply to solve this. So we can take this cross product, so that would be 45 times R minus 7, and that would equal this cross product, which is 38R. So I distribute, I'd have a 45R minus 315. And that equals 38 R. So we're trying to get R together, so I'm going to take this 45R and I'm going to pull it over to this side. So I'm going to subtract 45R, subtract 45R. Let me put it over here now. We'd have a negative 315 equaling a negative 7 R. Divide by negative 7, and then our R value is going to be 45. And that is a rate, so that's 45 miles per hour. All right, so two questions that they have are, what's the speed of the express? Well, R is the express. So your express is 45 miles per hour. And the local is 7 miles per hour slower than that, which is 45 minus 7, which will get you 38. So, turns out that they only traveled for exactly 1 hour. Who knew? Because if you go 45 miles per hour and you go 45 miles, you had to only have traveled for 1 hour to get that. So normally that doesn't quite work out like that, but that one is just kind of a coincidence. So, so we set up our equations. We solve for t, has a tendency to happen on these, but basically solve for the variable that doesn't have any plus or minus going on with it, and then set those two fractions equal to each other, cross multiply, and get yourself your answer. And then plug them in and make sure things work okay. All right, so that was our second example involving rate times time equals distance types of problems.